following Kanui's topic, fishing, and also being a time of makahiki coming up pretty soon, thought it'd be fruitful to talk about more an agricultural mahi'ai topic for today. So just saying this, and excuse me, I'll just sit down right here, but so plant now, food, things you can eat, or else, one day the children will go looking, hunting elsewhere for food. So, if we don't build plant food, build infrastructure, sustainability, in a landscape model, or even just for our homes, our backyards, one day, there won't be anything for the future generations. So that's why we gotta start planting now, whether it's actual planting or just other types of food, fishing, aquaculture, things like that. So another reason it's important is, there are on a multiple levels, Hawaiians, let me take my mask off, excuse me, but Hawaiians, Kanaka, were connected to the land and the ocean. Yeah, whether this be physically, back in the day, our ancestors were out in the sun, and I know we learn about Kanaka Helela, so those that move with the sun, but also, if you ever look at a farmer or just typical work day, we rise with the sun to be active during the work, and as soon as the sun sets, and that's when we go back to our homes to rest. So just like plants, we are Kanakas kind of like that, where plants, they react to the sun and they go when it sets. So physically on the land, but also culturally through our moral level. So everybody is familiar with the creation story of Haloa Naka, and then also the younger sibling that came after Haloa, the chief, and how we're connected genealogically for that story. So just to paint a picture, I think this is a KS picture, to cite anything, but so just a artist rendition of what an ideal Ahupua'a system looked like. You have resources in the mountains, trickle down to the human realm, where you have your agriculture activities going on out to the ocean. So this is, a lot of different models and sections for subsistence agriculture. You have your medicines, your lumber, timber up in the uplands, and then you go down into the food area, and then you also have additional food, medicinal resources in the ocean. So this whole subsistence and sustainable system. Reason called Aina because it's I, food, to eat, and then Na is that which, so that which feeds us. So a lot of definitions, vocabulary, just from how important food was to, is to people, as well as water. Hawaiian word for rich or wealth is waiwai. Back in the day, the island was very, very abundant and productive. So in early estimates, there were about 20,000 acres or more that were dedicated just to the kalo production throughout the state, throughout the nation, the chain. But then nowadays, I think it's at the most a few hundred acres. So it's diminished very, very greatly. So this is a very not only large part of their land area, but also given that they dedicated this large amount of area to this crop, just shows how important this crop was to our ancestors and still to us. And then you also have other descriptions from sailors when they would look onto the islands from the coast on their boats. And I would describe that it's like a large house that's just shaded by breadfruit trees. So it's just expansive across the landscape. So it just paints a picture. But, I don't know if we can get to this point, or back to this point. It might take a lot of work. But, we can start. And one of the best places to start to learn how to grow things is from the base, to build a good foundation. And that's a lepo. Okay, so lepo, soil, please don't say dirt, but it's soil, it has a use, provides us food, a lot of different other resources. My professor did a project out here in Wahiawa, and not to get into the nitty gritty, but they have a certain kind of charge out here that prevents fertilizers from getting into our aquifer, so very unique as opposed to places like in the States that have an opposite kind of charge, and they have a lot of nitrate pollution in their water because of it. So we're lucky we have the soils we do here. And being in Hawaii, we have, if you ever take a look, driving down here, anybody notice what color the soil is? Don't mention Dave, you're here. Did anybody know what color the soil is here? Okay, red. Okay, how about, a lot of you guys are from the east side. What color is the soil there in your backyards? Dark brown.
Clayish.
Clay, but then like if you go to Kali Woods house, what kind of soil texture you got?
Sandy.
Yeah, real sandy, so it depends on the topography, and even Vihikai, you know what kind of color soil you got in your back? Oh, you got reddish, okay. Yeah, so good. So you have a lot of different diversity in soil types, depending whether you're in a dry climate, wet climate, if you're in a valley area, like in a Loi, or if you're up in the mountains over here, or at the top, a lot of different factors that go into developing soil. So you can see that Nui Loa na Lepo Hawaii. So very diverse, and many are the soils here. There's different ways to classify it. We do it just by looking at it, observation. So you just describe colors. So you have red kinds, you got dark kinds, you got sandy kinds, you got rocky kinds, all depending where you live. But then even our ancestors, they had a classification system. It wasn't that complex as like some of the scientific ones nowadays, but they recognized these differences and said, there's Ula Lepo or Lepo Ula, there's red kinds, there's Palolo or clay, there's Momona kinds, very fertile for growing things. Even just grow rocky soils, or Akeke, which is cindery. So typically what you would find on Hawaii Island. And just so happens, these kind of match up to how modern scientists classify soil types. So these are just the names that modern classification systems use, but matches up almost as a group, description for description with what our ancestors also observed. And just another kind of cool fact about Hawaii, given our our very diverse climatic zones, we have 10 out of the 11 types of soil, or type 1, that's supposed to be 12. 10 out of the 12 types of soils that you can find globally. The only ones that are missing are the kinds that are frozen up in Alaska, and this other weird kind that you typically find in the Appalachians. So that's the only 2 types are missing. And here's just another cool picture of the global diversity. So here you can see the 12 main types of soil orders you find around the world, and Hawaii has 10 out of these 12. So if you ever wanted to find out more about your soil, just general knowledge, a couple professors and I, we helped to make this map. So you can either go on Google, or you can go on your phone right now, and you just type in Hawaii Soil Atlas to find out, and you just double click on the map. You can zoom into your backyard, you can zoom into over here and find out what kind of soil you have, general behavior, like expected pH, how well it drains, things like that. But one thing that you gotta fix is if you do visit this, use this HTTP, because the website, when it loads it, it's HTTPS, but that S somehow screws it up. So just gotta go into the URL and delete it, and it works pretty crystal clear. So you can try it now or afterwards. Yeah, but yeah, so just Google Hawaii Soil Atlas and you can have fun with this. But on here you can find, here's some of the descriptions you find for water, fertility, and even some graphs about when they were places they took data, what they found. So you can find general information about how fertile it is, what the pH is like. So getting back to it, we're mostly interested in soil because of the food it produces for us, floral plants, uses like that. And the main thing is soil fertility is key if you want that to happen. And there's a lot of things that influence how soils are fertile. So most of the time, if you look at a plant like this, it looks like something like a disease, a bacterial disease. 9 out of 10 times you think it's like that, but actually this is a nutrient that's missing inside of the soil. It's calcium. So some plants, if you don't have this, or sometimes if it's too hot and the irrigation system is off, your plants won't allocate that nutrient to this growing point, and you'll get this kind of symptom.
Is it bad?
It's not bad, but quality-wise, it's like that part's going to be mushy compared to the other parts. But if you kind of just using half of it, you can chop it off. But then the simple way is the next time you plant, you just gotta fertilize with that missing nutrient. Eat around it. Yeah, there you go. No waste. No waste. Yeah, so to understand or to know soil, we gotta understand it. And soil isn't just rocks and minerals, but it's more than that. So, like I said, minerals comprise about 45–50%, depending what kind of soil you have. And then the other 45, 50% is actually airspace, because when you put all these blocks together, there's gaps in between, and that's what makes these pores. But depending if it rains or it evaporates, you'll get this mixture of either fills up with water or it's mostly air, which you need for plants. Plant roots. They're as I'll mention later on in my presentation, plants, they're just like people, and people are just like plants. Okay? They need oxygen, they need water, they need nutrition, and they need space in order to grow. If you don't provide those things, then same thing with people. You don't give them oxygen, it's not going to grow too well. So you have those parts of soil, and then given that soil is it's filled with life, interacts with life, you have an organic matter fraction. Typically, it's about 2%, 5% in most soils, but then you have some soils like on Hawaii Island that are 20%, and even in the Pahoa region, you have ones that are maybe 60% organic matter or more. Okay? So it all depends on mineralogy and these other factors. So as I mentioned, there's a lot of different kinds of soils and factors that make our soils here. So it doesn't make sense to teach you all the different kind of types. So I want to kind of tie this in with Lua. So as I studied soil, I kind of picked up on this concept that applies very well to Hawaii soils, but particularly Oahu, because we have, as I mentioned, these features and characteristics on our island. So thinking of Oahu and duality and the landscape, what is one main characteristic or property of our island that has like a dual nature? We kind of touched upon it in La'au. Okay, very good. Okay, so Kamapua and Pele, we have a wet side and a dry side. That's affected by the mountain range where you're at. So, the Ko'olau side, because they get that trade wind first, they're going to be picking up that rain, that weather. So we have mostly the wet side. This side gets, similarly wet too. And then on the far end, sorry, Waianae, but, you guys just get the rain shadow, the dryness. Okay? Yeah, so that's one dual nature of Hawaii. So, given that, we have this, what is another dualistic feature of our islands that kind of drives rain patterns that I just mentioned? Good. Okay, good.
That's why not right there.
Oh, there you go. Yeah, and looking right out here, you can see it. So we have Kuahili. So this, Oahu, we have two beautiful ranges. Okay, we have the Ko'olau side, we have the Waianae side. But this is the high aspect, the Ku aspect. But more on that flatland area, you have the opposite side of it. You have the Awava, or the valleys, the gulches, and then kind of interestingly, a third subgroup that kind of ties in with the flatland area is the plains. Okay, so the Kula. So this Wahioa area right between the two mountain ranges is a perfect example of this. What collected from these two mountain ranges eroding over time. And then easily, you also have younger and older. So as the islands formed, at least geologically, it moved from west to east. So the Waianae ranges and side is going to be older. So actually, the area we're sitting on right now, Wahioa, is older than the places that formed on the Ko'olau side, which is the younger of the areas on our island. So all of these things, precipitation, weather, topography, whether it's mountain or flatland, and time, are the three things that influence how soils are formed. So as being dual, we have two kind of basic soil types. We got a Lepo Ula, which we see here, some other rainy parts of Kaneohe, because we see the red soils also because that the only thing that's left after all that rain leaching the nutrients out over soil formation is these iron and aluminum oxides. So you'll typically see on wetter sides, either mountain ranges that get a lot of rain, and also on relatively younger areas that didn't have much input over time. That's supposed to say older areas that got a lot of rainfall and not input over time. And on the second, the opposite end of it, you have this Lepo Palolo or a Momona. So this is, Palolo means clay, and in Hawaii, majority of our soils are clay, but this is the real sticky clay that you'll sink in. You can imagine a lo'i. So it's very fertile. It has a lot of nutrients, but then it's, you'll get stuck in there. So these are typically formed on drier pellet areas, the bottoms of valleys and gulches, because a lot of the rocks that form, they keep adding these nutrients to the top, so it never has a chance to drain out or wash away. And also younger areas. So this is, kind of generally how you can think of the different soils in Hawaii. So as I mentioned, the different aspects of soil that influence fertility, keep these things in mind. And I'll touch upon it too. Yeah, so for soil management in Hawaii and the tropics, generally you got to think of two things. So one is soil pH. So pH is is a master variable that influences mostly everything else. Mineralogy, which has to do with what that base soil mineral is, and it's related to the Lepo Momona and Lepo Ula things, and then just general nutrient management. Okay, so first is pH. So everybody is familiar with pH. You got things like acid. Anybody can name things that are acidic in your kitchen or household? Yeah, vinegar, orange, lemon juice, those kind of things are good. Even sodas. And then you also have things on the alkaline scale. So that's for basic. What is some basic things in your household? Yeah, okay, good. Soaps, bleaches, yeah, Clorox. Okay, so these are things that are slippery versus things that are more corrosive. And that nature of pH influences how things either dissolve or precipitate. So if you ever see pictures or a video of they drop a penny or they drop a tooth in soda or something acidic over days or weeks, that eventually that tooth decays or sometimes disappears, because the acid is acting upon it to erode and release those nutrients from the tooth. So that's why soil pH generally it's in a slightly acidic range, so you can get that release of nutrients. But if you have too much of a certain nutrient, because there are some nutrients that are bad, I'll talk about. If you want it to get out of your system, you just gotta force the pH to go the other way, so it actually precipitates and forms into a rock again. It can't affect your plant. And most of the time in soils, we're dealing with this 4 to 8 range. Hardly ever you'll see things way outside of it, but if you do, you're in trouble. Call me up.
Call me up.
Yeah. If you read articles, most of the time you'll see recommended pH level for vegetables or fruits is 6, 6.5, or 7. Yeah, and the reason for that is if you look at this graph. So this is a general graph of pH ranges where nutrients are most available. So you'll see on the red ends, that's where they're unavailable, and then in the green, that's where the most available. So where do most of the nutrient bars overlap, where you maximize nutrients for the plants? Okay, so right in that middle area. Okay, good. So that's why you want to keep it there for most crops. Things like pineapples, they like it much more acidic, so you actually got to lower your pH to grow, which they did back in the day. Okay, so this is ideal for most vegetable crops and plants. As I mentioned before, if you have a lot of heavy rain that leaches some of those things that make soil pH alkaline or basic, you'll get slightly acidic, maybe 5.5 to 6.5 in these Lepo Ula soils. Or if you intensively farm areas like they did with sugarcane, pineapple, adding these ammonium and urea fertilizers, you're gonna get very, very acidic soils. Sometimes you encounter soils like 4, 4.5, and yeah, very detrimental plant growth. Yeah, but on the other side, this Lepo Momona side, because it's drier, has a lot of its minerals still in it. Sometimes for coastal areas, because a long time ago they actually had some coral influence, so you have this calcium carbonate on the land. You can have pHs that are about 7, 8. Okay. So this is okay, but then you still have some issues, because if you go to 7 or 8, you'll notice you have these micronutrients missing. So it's a balance, and you want to try and know your plant and maximize where the pH is. So just some general pH ranges for fruits and vegetables. So as I mentioned, in most things, cabbage, eggplant, tomato, like in that 6 to 6.8 range. While most fruits, same thing, about 6, 6.5. But then you have things like pineapple, like it at less than 5.5 or 4.5. If you ever try to grow your own camellia tea, the kind of jasmine tea, chai tea, grow your own. That also needs 4 And another big crop that they're trying to do is blueberries. So if you ever do grow blueberries, you either gotta grow it in acidic soil, or if you grow it in pot bags, you gotta buy these acidic types of media, like I think they're using peat, or I think that was the main one. So they have to use special media just to grow it, or they acidify it. But the bad thing with having low pH is, one, not only you don't have as much nutrients, but sometimes you actually have too much of bad nutrients. So this is aluminum. So as I mentioned, in these Leppo Ula soils, you have a lot of aluminum and iron. And if you have too much aluminum, it's bad for root growth, because aluminum is it's a big atom. So it outcompetes the space on the roots with other nutrients. So it can't take up potassium, calcium, things like that. So you get stunted root growth, and without a strong roots, strong foundation, the plant's gonna either be stunted or won't grow. Yeah. But as soon as you increase that pH to above 5.5 or 6, the aluminum, just like that tooth, kind of solidifies. It can't interact with the root as much, and you'll have regular plant growth. So the way you do that is you generally, there's a couple of different ways, but the main way is you increase it by adding lime. So you either hear the term agricultural lime or dolomitic lime. These are chemicals that react and neutralize acid, and that increases pH. So you have these kind of curves where if you just type in Hawaii pH curve or acidity curve, you'll find this for different soil types, because different soils have different minerals in them. But generally, if you're at pH 5 and you want to get to pH 6, this tells you how many pounds or tons of lime you need per area. So it takes a little bit of math to do the conversion, but with our friend Google, you can do anything. Yeah, but if you're on the opposite end, such as Waianae or coastal areas where you have maybe a slightly more alkaline pH, it's a little higher, which is bad because it can have that micronutrient deficiency, like I mentioned. Although it's micro, plants still need a little bit of it. So to fix that, you can either add elemental sulfur. It comes in either capsules, granules, or sometimes powder. But if it's a fine powder, just always be careful not to inhale it. Or if you're okay with using synthetic fertilizers, urea, ammonium type fertilizers, over time, they'll add protons and acidic elements to the soil. So you'll drop it over a couple of years. So that's how these soils over here, which naturally, back in the day, they're rainforests. And the pH was maybe about 6, 6.5, but then after intensive agriculture for decades, that's what brought those down to like about 4 because of these ammonium and urea fertilizers. So that's general about pH and how to manipulate it. We're mostly interested in pH, how it influences minerals and nutrients. And some soils actually don't need added nutrients. Okay? So for example, Lulule, so Waianae side. This soil type, it's in a drier area, so there's not much rain to leach away nutrients and wash it away over time. So if you look at this graph on the bottom, or this table on the bottom, this is the measurements that NRCS has taken, but it naturally has good pH. So this green is where you want to be as a target, which is 6.5. pH is fine at 7. It has enough calcium, almost double what you typically need for vegetable crops. Almost quadruple or 6 times the magnesium, and the potassium is double also. So most of the time, when you're growing it in these types of soils, you only got to manage for nitrogen and maybe some micronutrients once in a while. So easier on the fertilizer costs. But then, as soon as you get to these more rainier areas, or Wahiawa is not as rainy as the windward side, but you can imagine the windward side. Over time, it had erosion to add to the landscape, but over here there's nothing to add, so that's why over time it just generally drains. So that's how come it's red here now. So it's developed over wet and high leaching conditions over time. So as a Leppo Ula soil, the pH it's lowered at about 5.4 with some addition to ammonium and urea fertilizers, but generally the calcium, the magnesium, potassium have been leached out. Okay, so if you are on a new piece of property that hasn't been managed before and it's in these Leppo Ula soils, typically you gotta either adjust pH and or manage for nitrogen and these other nutrients like calcium. But when you adjust for pH in these epicooler soils, as you know, limestone, the chemical equation is calcium carbonate. So you're adding not only things to increase the pH, but you're also adding calcium. And if you use dolomite, that has magnesium too. So just throwing it out there. So for plant nutrients, plants don't need all nutrients at the same rate. Okay? So if you look at this barrel, it's called the law of the minimum. So basically, you only can grow as much or hold as much water as your most limiting nutrient or the one that the plant needs the most. Okay, so these being your nitrogen, phosphorus, and potassium. Okay, so these are macronutrients, but the plant needs in great amounts because they make up about 2% of the plant's biomass. The other majority is carbon and oxygen, things like that. But soon after that, you need next greatest nutrient you need is calcium, magnesium, and sulfur. And then, like the name implies, you need micronutrients in very small amounts, but these are things like iron and zinc. And rather than test your plant every single time, there's some signs you can use to figure out what is missing by looking at if the older part of the plant or the younger part of the plant is showing some kind of sign of yellowing or stunting. So if it's on the older part of the plant, it's usually going to be nitrogen, phosphorus, potassium, or magnesium because these are mobile nutrients. So by that, it means, as the plant grows, it's going to have it in its leaf part, but it's always going to prioritize the young shoots. So kind of like how I said, people in plants, we always try to prioritize our keiki, the youth, for growth. Okay, so plants the same way. So these kind of nutrients, if they have it in their leaf, but then they're, it's missing in the soil, they're going to move those nutrients from the bottom of the plant to the top. Okay, so you'll see it kind of turn yellow from the bottom, but the top stays green. That's how you know the mobile nutrients missing. But there's some nutrients like the micronutrients that it's immobile in the plant. Once it gets in the tissue, it can't move it around. So you'll see the top of the plant start to turn yellow while the bottom stays green because those nutrients are still in those tissues while the top is missing. So that's how you can tell if you have that kind of issue. So just showing you pictures for odor deficiency symptoms. So you'll see in nitrogen, it's going to have a just general yellow or chlorosis of the odor leaves first. Okay? So you can see the top is green, the bottom is yellow. For phosphorus, you'll see on the odor leaves that the odor leaves turn either a dark purple in some grasses or corns, or if you have other kind of plants like tomatoes, eggplants, you see it turn like a very, very dark purple. Some plants as their seedlings, they kind of show this, but if it doesn't disappear as it grows taller, then you'll see that too. And then for potassium, you'll see the odor leaf on the leaf edges, it'll start to turn yellow. So potassium, it's kind of tied with water, so this may also be water stress. But if you know it's been raining or you water regularly and it's not burning, then it may be a potassium thing. And also if you have small fruit production, you may be missing potassium. Another one too, we'll start on this side for the odor leaf, magnesium. You'll see interveinal chlorosis, so the plant leaf rib and the veins will stay green, but then the in-between parts will turn yellow. If that's on the odor leaf, most likely you got a magnesium deficiency. And then going to calcium, which is a new one, you'll see the new leaf start to crinkle up because it's an immobile nutrient, which calcium is needed in cell walls, things like that. Kind of like our teeth, the plants need it for their strong outer exteriors of their leaves. So you see it as a stunting on the new leaf or on the fruit as we saw before, you'll get underdeveloped fruits. And then just some other deficiency symptoms for the micronutrients where for the new leaves, it'll show either a yellowing, interveinal yellowing, or it'll show some other kind of stunting. Okay? And then sometimes for papaya, if you're growing it in a boron deficient soil, it'll start to get crinkled and now misshapen. Okay? So you might be thinking, I want to make sure my plants have all the nutrients they need. So why can't I just add, everything one time? So for one, if you add too much of something, it can either, for nitrogen, it can burn your soil, burn your plants. It can, some plants may not flower as much because, plants, if they get as much nitrogen they need, they won't stress out and make flowers to make fruit because fruit is a reproductive mechanism. Okay? So if you keep feeding a lot of nitrogen, you may get poor flowering and fruiting. And also, if you add certain other kind of nutrients, they outcompete other ones, or they make other nutrients less available over time. So that's why you don't ever want to just apply tons and tons of certain ones, because for these reasons. And also for boron, if you ever over apply boron, that just burns plants too. So it's something to be careful of. So for fertilizer management, as I mentioned before, we want to be careful how we apply that. So, how much, we don't ever want to under apply it, because our plants are not going to grow. They're going to have poor quality, poor production. But then we don't also want to over apply for those reasons I mentioned, but also for environmental and economic reasons. So for one, fertilizers, they cost money to apply. So if you apply a bunch of it, and there's a heavy rainstorm and it washes it away, there's your money going down the drain. Okay? But also, that water that is filled with these fertilizers and nutrients, as it makes its way through the streams, to the oceans, it impacts a lot of animal life and also plant life. Where some UA studies found that nitrogen fertilizer running into the oceans was one of the main causes for these weird tumors they were starting to see on turtles. Okay, so that's one reason why we want to be good stewards of the land, make sure it's sustainable, not only for us, but for other parts of the ecosystem. Okay, so knowing how much is important, but also when to apply. So this is just a general growth curve of, looking at the corn one. This is like a growth pattern of corn. So, from seedling, it grows to when you harvest. So I know a lot of times when people plant plants, they dig a hole, they put the choke fertilizer inside the hole, they put the plant right inside, okay, you're good to go. But that's like if you were to add all this fertilizer in the beginning when the plant's small, and then when the plant needs it the most, it's not there. So you want to maximize the growing point. So you can kind of think of it like plant growth, kind of like humans. So as a child, as a baby, they need food, but they don't need too much food. But then as you get these rowdy teenagers and they make you off bug, like how I did not do as a kid. Those guys, they eat you because of their growth spurts. They eat a lot of food and always bottomless pit all the time. So that's kind of like a plant. During that active stage, that's where they're needing most of their nutrients. And then as they develop and mature, that's when you can kind of maybe back off. Okay? So mostly during that growth period and growth spurt is when you need to add it. And we've done this through a fertilizer experiment. So this is a cabbage crop. And initially the farmer, they were adding, kind of how most gardeners do. They add all the fertilizer in the beginning. So this farmer was adding almost 300, 400 pounds of this urea fertilizer all in the beginning. And just when the plant was starting to have its growth spurt, it cut back to the lowest amount of fertilizer added, and after that didn't add anything. So he got all that excess nutrients in the soil kind of stayed, and you got one type of yield. But then when my professor and his student, they kind of compared with the farmer, and they actually added more, less, very, very little bit in the beginning, but more towards the growth spurt when the plant needed it. They got the same exact yields. So it's matching the application to when the plant needs. So as you plant things, don't always add it to the beginning, unless it's like organic fertilizer that I'll talk about pretty soon. If it's like a synthetic one, try to space it out to when the plant's going to actually need it. So it's talking about different fertilizer types. There's two main types, a synthetic type, inorganic, and an organic. So for the inorganic, the synthetic type, mostly has to do with urea. So if you see 4600 or 301010 or 201010, 616 is a very popular one. These are all synthetic forms that they'll break down easily in water and in the soil, and they'll immediately release these plant nutrients, nitrate and ammonium, that the plant eats. And it's very simple form, so it's readily available for the plant, but it can also transform quickly. If rain happens, it's going to wash away, or it can turn into a gas. So you just got to be, like I said, to maximize the effectiveness of this, you want to be able to time it when the plant's going to need it, so you don't have any waste. The other one you have is organic fertilizer. So these are things like, most times people are going to think of compost, but compost it's a very, very poor organic fertilizer. It's more a conditioner because it doesn't have nutrients. But things that do have nutrients include like a lot of fish meals, bone meals, feather meals. You have manures, that have phosphorus, things like that. But you just got to be careful from a food safety standpoint. You don't add that manure, too close to the part of the plant you're gonna eat. Those kind of things. Yeah, but organic fertilizers, pretty good, but then they're lower than your synthetic ones. So not sure if everybody know how to read that number on the bag. What's the first number represent? It's the month, the day, and the year. Oh no, so this so you gotta just remember NPK. I think that's not alphabetical. So just remember NPK. So it's nitrogen, phosphorus, and then potassium. Okay, so the bigger the number is, that's the more percentage it's inside of that fertilizer. So this triple 14 has 14% nitrogen, about 14% of this P2O5 or phosphorus, and then 14% of potassium mineral. Okay, so you have high numbers for some synthetic ones, 46% nitrogen, this and that. But as you get to organic ones, the highest nitrogen you're typically going to find is 10% or 12% nitrogen. You won't typically find more than that. For potassium, you can find things like 0, 0, 50, or 42, but that's the exception. So organic fertilizers, they're good because not only do they provide nutrients themselves, they can also provide charge where nutrients can be held. So as I mentioned, soils have different charges, and when you add organic matter, you add this negative charge to the soil that can hold on to calcium, potassium, things like that, which is helpful. And then also for some, Lepopula soils that have that aluminum toxicity issue, as you add organic matter, it can actually cling onto it and capture that aluminum, so it can't interact with plants. So that's why on Puna soils on the Big Island that have high organic matter levels, but then they have a pH of 4.2 or 4.1, you'd expect some kind of issue. But because they have so much organic matter, they don't have any aluminum problems there. Okay, for that reason. Okay, so that was chemically, but we also like physically. So you'll see on this soil map, a lot of different soil types on Hawaii, but two main kind of drainage patterns. You have well-drained soils like the Lepopula, they drain very well. Some other mountainous ones, volcanic soils like on the Big Island, do really great. But then once you get to those Lepo, Palolo, or Momona soils that are darker, very, very adobe clay-like, they drain very poorly. So you'll find those in the valleys or in dry areas like Waianae. And but one thing or one benefit of adding organic fertilizer, organic matter too, is it helps with that drainage, whether you're in a Lepo Ula soil or a Lepo Momona Palolo soil. So if you have a sandy soil, like Oloi Kaligua's one, that organic matter is like a sponge. It can help retain water, which can then help retain nutrients. But then if you're in a clay type soil, that sponge actually kind of spaces out the clay particles. So you actually get a little bit fluffier soil, slightly better drainage. Okay? So that's kind of what it does. It makes these root clods that you would see if you pull out a plant and have things sticking to it. That's kind of what happens over years of adding organic matter. And another benefit is biological. So organic matter, it comes from living things, and it also has living things. So you have different kind of organisms. So this worm type thing is a nematode. So if you ever saw nematode problems, I wish I had a picture, but you'll see these root knots on top of them, and it makes things either unsellable or the plant doesn't grow, it gets stunted and it dies. But by adding certain types of organic matter, you can actually add these predators to nematodes, they're competitors, and you get less problems. Almost done. But there's a couple limitations for organic fertilizers. So as I mentioned earlier, the inorganic ones, they're very simple. So the plant can utilize them very quickly, like the nitrate on the right side or the left side. But then once you start adding these organic compounds, they're so complex, the plant can take it up as it is right now. It takes time for it to release the nutrients. So it's a slower release, which is good and bad. Yeah, so just showing it, if you have a plant that needs about 200 pounds of nitrogen per acre a year, you can meet that immediately by adding only 400 pounds of urea, which is available 100% like that. But as you start adding meals, which is lesser in amount, as well as it releases maybe only 70, 80% in the first 3 months, you'll need more of it. And then once you get to compost, which is 1% nitrogen, and it releases only maybe 10% of that in the first year, you're going to need tons of that in order to meet that same requirement. So you have to balance that. But the benefit of this is because it's so slow releasing, during that maybe 5th year or 6th year, where most of the nutrients been released, and you don't have to add as much fertilizer because you have this as a slow release fertilizer over from previous years. Yeah, so what kind of soil do you have? As I showed before, you got that soil atlas you can try to check out to find your basic soil types. And then you can also do a soil or plant test to a lab. And if you ever do gotta submit a soil test, real easy. You don't want to just take one sample there and call it a day, because maybe there's something in that spot that you picked that might spike your results, or won't tell you what's in your overall area. So try to take a zigzag representative pattern and mix it up in a bucket, and then from that bucket, that's what you throw in your bag to submit. So you can either submit it at UH. We have a lab. I think given COVID, it's just started reopening. So if you're interested, let me know. There's cost, but it's maybe $12 for one sample. And then there's other guys that are available too that provide good soil test results. Generally, you're gonna just get a result like this that shows, if your nutrients are low, then you'll have to add fertilizer. But if they're adequate, sufficient, or if they're too high, then don't need to add anything at all. And then you want to pay attention to this because, as you said, there are different kinds of fertilizers. So there's blended types that have all the nutrients, N, P, N, K, versus ones that just have that first, maybe nitrogen. So if you notice, you have your soil test says it's high in phosphorus, potassium, but then you don't really want to add a blended one, because sometimes not only does that add to the problem and if that runs off, that gets into the oceans, all that environmental issue, but they can also be more expensive than just the straight nutrient itself. So you're not only protecting the environment, but you're also saving money and costs. Yeah, so they'll give you that level, and then they might also give you an amount to add per acre or per square foot. And if you, you're not going to have 100 square feet exactly, you'll just have to do some math. So you'll just put in 100 pounds per 100 square feet. If they give it to you like that, there's 435,100 square feet, or 43,560 square feet in an acre, and you just convert that to the pounds you need. Who's Josh? I don't know. I don't know who that is. But call him. So there's a lot of information. We kind of went from the traditional to the more modern and real scientific nitty-gritty of it. But generally, we want to promote plant growth in our backyards, in our communities, whether it's to feed our families for every day, or even just like a couple meals a week kind of thing. Not only do we feed ourselves nutritionally, but we also feed our souls and get that reconnection with the INL, with our environment, things like that. So just to get proper plant nutrition or proper plant health, good nutrition and understanding of soil is required. Try to keep that soil pH in that desired range is key first. Know your soil type, whether you have Lapu'ula or Momona, and then you'll know which things may be missing and what things you need to add. And then, as a good rule of thumb, adding this organic matter is good physically, chemically, and biologically. And then if you want to get to the real details of it, you can always do a soil test to find out more. Okay. So yeah, thank you. I can take questions, and just thought I'd throw a picture out here that from my time, you guys know I've done research in Pohnpei and Micronesia. And when you go to visit them, they don't add a single ounce of fertilizer, but they produce tons and tons of breadfruit, coconut, mango, bananas every single year. And that's because they kept their old ways. They never converted to maybe a more modern style where tilling and breaking up the soil, which is good for the roots. But once you get in that cycle, that actually destroys organic matter and nutrients in your soil. So now that we're stuck in this cycle, we just got to continue with it. But if you're able to establish something like this, or have someone that has something like this, try to keep it, because these have been going on for generations and millennia. And what I believe that our ancestors had back in the day, and that's how they fed themselves, and we're only able to fertilize with leaves and minimal things like that. So yeah, if you guys got any questions, let me know, or you can call up that guy, Josh. Okay, so the question for the Zoom guys, so from Lee Kai, he asked if, as you know, the Waianae Ahupua'a, if you look at the maps, it's stretched also into central Oahu, where now I guess Wahioa, and if the red Lepu'ulasos had anything to play with it. For that, yeah, I'm not too sure. I'm not sure if it's a water-related issue, maybe because this side maybe had a stream or some kind of thing they could tap into. Yeah, that I really don't know what the driving factor is, but because I know I've heard of there being water and lo'i in that valley back in the day, but I'd have to take a closer look. Yeah, but I mean that's the thing. Like if it was only at the top versus yeah, so maybe they had to allocate more resources. Yeah, good question, but
I think just to respond to that, I think the comment is if you look at the Ahupua'a as one self-contained unit, it could be that they drew that line up there because maybe they didn't have as much down at the coast or in that area, and so they decided to compensate for that because the whole idea was you were supposed to survive within that one land division. That makes sense.
So the comment from Nohoa was that I guess kind of agreed that the extension of the Ahupua'a was the Ahupua'a system needed to have all the major resources needed by a community. So they maybe extended it into those areas because there was something deficient in other parts of the Ahupua'a lower down the coast or something like that. Mahalo.
What is a good all around miracle grow?
Question was if there is a recommended all around good fertilizer, and as I mentioned in my presentation, it's going to depend because then when you get into if you get into like that silver bullet kind of fertilizer, you're always going to get into that habit, and you're eventually going to get excessive in some nutrients. So my recommendation, although it costs money, is to just get a general fertilizer test to see, or soil test to see where you're at, and then based on that, you can get a good recommendation for your area. So sometimes a good general fertilizer is going to be 1616 or 30-10-10 because it has general things that you need. But if your pH is off, none of that's going to matter, and you're going to have to add that too. So it depends, but yeah, generally like a 30-10-10, if it's used correctly, would be good. 1616 is okay too, but eventually that you're gonna have a lot of phosphorus. And then if you know that you got everything is good except nitrogen, then yeah, the urea fertilizer or feather meal. And also another good sustainable product that's being developed in Kapolei, so Island Commodities. They're in Campbell Industrial Park, but they take all the rendering waste from slaughterhouses and the fish markets. Real stink stuff, but they process it, cook it up into a good powder, and that has like about 10% nitrogen, 3% phosphorus, 1% of potassium, so it's pretty well blended, and it's adding organic matter too, so that's another good option, and it's pretty inexpensive at, I think it's like 35 cents or 40 cents a pound. So if you go with a trash can like that, maybe it costs you $10-15 to fill up. Shout out.
How good is the worm dropping?
The worm castings? So worm castings, I don't know the exact numbers off the top of my head, but it's like about 5-3-1, so 5% nitrogen, 3% phosphorus. But it's, you're gonna need a lot of that to add to a certain plant. So it's more maybe a supplement that you can add in a slurry or a watering mixture. But then it's not really, you shouldn't rely on that as a fertilizer source as itself. Maybe you can if you have other nutrients in the soil already, but typically you gotta add that with something else. But then that's a good thing you can add for the biological activity that can help release nutrients for the plant too.
How often do you get to see your kids in Micronesia?
My Zoom and Skype is
Junior's got his first goal.
last 2 years, it's people on the wait list. There's about 400 people on the wait list.
So the comment from Holu is that the Honolulu Zoo has a composted animal manure that you can get for free. You just gotta sign up but you gotta be on wait list though.
Number one, he knows
Okay, so very interesting point. So Dave's question was, how does lightning affect soil? Because as growing up, you remember his grandfather mentioning that lightning was good for the soil. So that mostly has to do, from what I imagine, with nitrogen. So there's three main ways that nitrogen gets in the soil. So one, you industrially process it to make this urea fertilizer. Two, you get it from I guess plants breaking down, living debris breaking down, which those plants would have gotten it from taking it up as a biological nitrogen fixation, things like that. And the third one is either through acid rain or lightning. So it's getting into chemistry, but nitrogen gas, N2 gas, which is 75% of the air we breathe, it's N2, which is linked by a triple bond. So it's very, very strong and tough to break. But one of the things that can't break it is lightning.
Bring it up.
Triple bond. So it's lightning. So whenever lightning strikes, and if there's nitrogen in that air, which it's going to have, that could release some atmospheric nitrogen either into the air. I'm not sure if the soil. I imagine if there's nitrogen gas, air in the soil, it could release some of that that's in the soil. So that too, that would release it inside of the rain. So that's my, educated guess on why the lightning is good. So Holu mentioned that there's a documentary that showed there's a relationship between silt and things from the forest feeding the oceans, but then that's why, remember how I mentioned there's runoff from the fertilizers that goes to the ocean. So the natural system is gonna let some of that nitrogen, phosphorus go and produce a good amount of kelp and seaweed, which is good. But once you start getting excess nutrients going to there, you'll get a lot of seaweed and algal growth, algal blooms. But then, like I said, plants, which seaweed is one of them, is like people, and it's gonna need oxygen, and you're gonna suck all that oxygen out, and that could cause fish die-off. So that's where this industrialness might get in the way of the natural system.
A lot of places upland, you get all this cattle and all the species
that's
that
nutrients.
go down the river and stream.
Yeah, that's
Well, that runoff